Y'all are taking the quiz on Canvas. CO Q1 quiz over circles equations. Don't use anything aside from a calculator. It's going to have a 15-minute time window. So the agenda for this week, and I will post these notes so you guys have this in writing as well. We got pen pals today. We got the circle quiz. You have lesson 1.1 on functions, and then homework 1.1, which is also on Canvas and Go Formative. Wednesday, you're going to have a new pen pals assignment, and there's going to be a video on how to create a flipbook and what you need to add to that flipbook. Thursday, we'll have the last pen pals assignment. That's when I want you guys to actually submit it. We'll have a quiz over the material we covered today, and then we'll do lesson 1.2 on domain and range. I should add in a reminder, there are office hours at 9:30 tomorrow morning if you need help. I'm also available via email, as some of you have already figured out. All right, so what we're looking at today are functions, and whether or not, how we determine if a relationship is a function, how do we determine if something is a one-to-one function, how do we find outputs given an input for a function, and how do we solve for inputs given an output of a function via graph, table, and equation. So a function is a rule for a relationship between an input or independent quantity and output or dependent quantity in which each input value uniquely determines one output value. We say the output is a function of the input. So for some quantities like height and age, there are certain relationships. Like if I know that I am 31 years old, I know my height is, I'm 5'6". But if I'm 5'6", do I know that I'm 31 years old? So the first question here is height an age, or is height a function of age? So is height a function of age? That's asking us if we know age, do we know the exact height? So if I'm 31, can I be two different heights? Because that would be what would stop it from being a function. So in the chat, tell me yes or no, is height a function of age? So remember, the input cannot repeat, so I can never be the same age twice. For something to be a function, an input cannot repeat. Is the age repeating? Age is not repeating. Output can repeat, so it can be the same height multiple times. So since age never repeats, So I have unique inputs here. Height is a function of age. Because I know if I know my age, I know my height. However, if I know my height, do I get one specific age? So if I know height, do I know my age? No, because you're the same height for a lot of time, right? I've been this height since 7th grade. I was a tall 7th grader. So age is not a function of height. Since height can map to multiple ages. What the Go formative does for you guys is it serves as a place where you can have your notes kept. So we do know that height is a function of age, but age is not a function of height. All right, at a coffee shop, the menu consists of items and their prices. Is the price a function of an item? So if you know an item, are you guaranteed to know the price? Like, is there only one price that corresponds to the item? Including size. So if I walk up to a Dutch Bros and I say, hey, I want a medium white hot chocolate, am I going to get a specific price, or are they going to be like, yeah, today it's $2.50, but tomorrow it's $3, and yesterday it was $1.55? So there's only one price that corresponds to each item. Okay, but if there's a discount, when it's still, you know, the specific price for that item in that moment in time. Price is a function of an item. All right, but if I walk up to Dutch Bros and I'm like, hey, I've got $5. Is there only one item I can buy for $5? Or however much? This is in the textbook. If you guys have the textbook and follow along, or you have it open, that's fine. I'm gonna modify the textbook so we can actually work through the examples without having to read what they wrote yet. So you don't need the textbook to do the assignment. So price is able to map to multiple items. So like if I have $2.50, I could buy a medium chai latte, I could buy a medium hot chocolate. There's multiple things, multiple outputs for a single input. So item is not a function of price. It helps me to make little maps like this to see inputs and outputs and whether or not it's mapping to a single output. If it only maps to one output, that's when it's a function. I'm going to skip example 3 because I hate the wording on it. I want to know, are either of these two examples one-to-one functions? So a one-to-one function means every input has only one output and every output only has one input. Are either of them one-to-one? Nope, because the age maps to, I'm sorry, the height maps to multiple ages, age maps to a single height, so it doesn't work both ways. Basically, it has to work both ways for it to be one-to-one. None of the above examples are one-to-one. Okay, so let's consider a bank account. I'm a teller at a bank, and I have a bank account number. And if I put that bank account number in, am I going to get a single output of my balance? Or could it show more than one balance for my bank account number? That's what it's asking. It's saying, is balance a function of your bank account number? So here my input is account number. Output is balance. Do I get only one output for a specific account number? I hope so. This is separate from time. Like obviously your bank account amount would change over time, but like if you're checking it in that instant. So yes, this one is a function. Balance is a function of account number. But if I walk into the bank and say, hey guys, I've got $500 in my account. What's my account number? Is there possibly going to be more than one account number that maps to that balance?
Yes.
Yeah, so is it a function?
No.
Not a function, because more than one account could map to a balance. Can y'all hear Louis? No. I don't know what he's whining about, something. All right, any questions up till this point? So take a pause if you guys have any questions about determining if a situation is a function or not. Okay. All right, so function notation, f of input. We read output is f of input, output is a function of input. Introduce function notation to represent a function that takes as input the name of a month and gives as output the number of days of the month. So output equals a function of input So in the chat, give me an example for this with numbers and a month name. So like I'll start with 31 is a function of January. In a non-leap year. Good. So in a non-leap year, 28 is a function of February, the best month in my opinion. We've got 31 is a function of July. Did I get any 30s in there? Aha, Emma R tells me November. Just show of hands. If you're trying to remember which months have 30 days only, how many of you have to do the rhyme? Use a little raise your hand tool. Or do you guys just like know? Only 2 of you? I don't believe it. 30 days has September, April, June, and November. And then there's a little bit about all the rest have 31 and then something, something, I don't know. Okay, so in this one, we do have to clarify this is a non-leap year. Otherwise, it wouldn't work for February, right? Because we'd have two outputs for the same input. Roxy, you never heard that rhyme? 30 days has September, April, June, and November. That's how I remember it. What? How do you guys know which months have 30 days if you've never heard the rhyme?
We don't.
Oh, you just like look at calendars? Knuckles? Victor, how? Okay, I'm gonna have to look up this knuckle thing. I've never heard of that in my life. The raised knuckles? All right, I don't know. All right, so a function n equals f of y gives the number of police officers in a town in year y. What does f of 2000 equal 300 tell us? So f of 2000, the input here is 2005, and that's year y. So the first thing we're going to say in year 2005, because that's our input, there are, and now we're looking for our output, which is n, and our output is 300. There are 300 officers in town. Still trying to figure out that knuckle thing. Y'all trying to explain it to me in the chat, but I don't even know. Emma R, do you still have a question, or you just have your hand up from the rhyme thing? Okay. All right, so any questions about example number 4 or 5? Okay. Tables as a function. So we know a table is a function if it does not have a repeating input. So we look at their example here. You see how none of the inputs repeat. They all have an output that goes with them. A non-example here, this is a non-function because our input has a repeating value of 5. If we want to look at table 2 in this image, we see each input maps to only one output. So none of our inputs are repeating. However, we have an output that repeats. So this is a function. But since the output repeats, it's not one-to-one. So in a one-to-one function in a table, we can't have an input repeating and we can't have an output repeating. So on example 6, it says, which of these tables define a function, if any, and are any of them one-to-one? So the first thing we're going to do is check for function. The first one, do any of our inputs repeat? No inputs repeating. So yes, it is a function. The second one, we don't have any inputs repeating, so it is a function. The third one, we have a repeating input, so it is not a function. So to check for a function, see if any inputs repeat. To see if it's one-to-one, we look and see if any of the outputs repeat. So none of the outputs repeat here, so this function is a one-to-one. However, we do have a repeating output here, so this one's not one-to-one. And this one's not a function, so we don't even have to check. But there is one case, if your inputs repeat and the outputs are the same. So for example, if they had done on this one, if they had made this like -3, yeah, that still would have been a function. They just listed it twice. So as long as it still maps to the same output. So if it's the exact same input output repeating, doesn't matter. Good question, Emily. So duplicated points don't count. So duplicated points can be omitted. Great question. All right. If each percentage earned translated to one letter grade, would this be a function? So if I earned a 55%, do I know what letter grade I'm going to get? Yeah. If I got an 80%, do I know the letter grade I'm going to get? Yeah. If I got a B, so let's say yes, this is a function. To check if it's 1-to-1, we have to go the other way. If I got a B, do I know exactly what percentage I got? No. I could have gotten 80. I could have gotten a 84. Could have gotten like an 86. A passing one, sure. But it maps to multiple different percentages, so it's not 1-to-1. It is a function, but it's not 1-to-1. Any questions here? All right. There you go. All right. So when we're working with functions, there's two things they typically ask us to do. Either evaluate a function like g of 3, that means given an input, find the output, or to solve a function, which means given the output, find the corresponding input. In this one, we're given a table where n is our inputs and q is our outputs, and we're told to evaluate g of 3. So if 3 is my input, all I need to do at the table is see that there's a 7 for the corresponding output. When you give your solutions like this, write them out like g of 3 equals 7. All right. The next one, however, asks us to solve for g of n equals 6. And you guys may realize there's a little bit of an issue here. I saw one question already in the formative. We have two outputs that are 6. So that means we're looking for the inputs that give us 6. And so n is going to equal 2 and 4 here. So we have two possible inputs giving us the same outputs. When we list multiple inputs, we like to put a comma in between them, kind of like we did for quadratics back in AGS2. I think another way I wrote it to accept was g of 2 equals 6, comma g of 4 equals 6, something like that. Any questions on how we got the solution for A or for B here? No? Okay. All right, using the function in example 7, it says evaluate g of 4. So our input is 4, and we already know our output that goes with that one. So our output is 6, so g of 4 equals 6. Yes, we would need the table to answer that question, or we would need an equation or a graph. So we would need something to be able to solve the g of n equals 6. So this is the example with the table, and we'll look at an example with a graph. So for the graph, I'm going to do a function right here real quick. I'll just draw a nice, happy little straight line. I'll call this f of x. I want to know what f of 2 is, assuming that these are counting by ones. So in this case, f of 2 would be 5 because they're giving me my input of 2, so my output is 5. And I want to know what value of x would give me an output of -5. So I'm telling you my y value here is -5, which seems to be this point here. So I find the x value that corresponds to it. And so I would say f of -5 is -5, or I could say x is -5 here. Good. All right. Looking at these graphs, we're asked to determine which one of these are functions and which ones are one-to-one. So that first one, is it a function? Do any inputs have multiple outputs? That would be what would stop it from being a function. Thanks. Mac, your answer's a little confusing to me because it's like, what are you answering in each one of those? This first one is a function. All inputs have only one output. This one is also a function, same reasoning, but this one is not a function. If we were to do the vertical line test, we see that the inputs have more than one output. So it's not a function. Womp womp. Are any of them one-to-one? So to be one-to-one, every output can only have one input. So if I'm looking at this first one, I look at the output of -2, I see there are 3 inputs there that work with it. So this one's not one-to-one. This one, however, is one-to-one because it does pass what we call the horizontal line test. So a horizontal line test, I draw a horizontal line through my function, and if it crosses more than once, it's not one-to-one, but if it only crosses once, it is one-to-one. So if it passes both horizontal and vertical line test, it is one-to-one. So vertical line test determines if it's a function. It has to pass that in the first place. And then we do vertical and horizontal to check if it is one-to-one. Any questions on that? Any questions about like what the horizontal and vertical line tests are? Oh, look, it's a special box. Nice box. All right, so given the graph of f of x, evaluate f of 2. So we're given an input of 2. We're going to follow it up and we find the output that corresponds. So we'd say f of 2 equals 1. I know y'all are tempted just to write the answer as 1, but get used to writing it in function notation. Solve f of x equals 4. They're giving us the output is 4. And they're asking us to determine the input. So our output is 4. What's our input? We've got 2 answers here. our inputs would be x is -1 and 3. Good, Roxy. All right, the try it now 5, it says use a graph from example 9 to solve f of x equals 1. So our output is 1. So x would be 0 and 2. We have 2 possible inputs that yield the same output. So is this quadratic function 1 to 1? The graph shown, is it 1 to 1? Send it in the chat. Correct, Tom. Correct, Elmer. Correct, Roxy. Correct, Joey, Sean, Andre, Jana, Nova. Yep, Annabelle, Bridget, Emma K. It is not 1 to 1. Quadratic by definition cannot be 1 to 1. That's correct. Good job. Doesn't pass the line tests. All right. So formulas as functions. We've done formulas as tables, and we looked at whether or not they're functions, we've done relations as tables to see if their functions are 1 to 1. We've done relations as graphs to see if they are functions or if they are 1 to 1. And now we're going to look at them as formulas. And we're going to see if we can evaluate and solve. We have this relationship, 2n plus 6p is 12, and we're asked to solve it for p equals a function of n. So what this is basically saying is solve for p. Okay, we know algebra. Hopefully we know algebra. If we don't know algebra, we should be coming to office hours very, very steadily. We're going to subtract 2n from both sides. So I get 6p is 12, take away 2n. And then we need to get rid of the coefficient of 6, so we're going to divide it out. Goodbye, 6. And we get p is 2 minus 1/3 of n. So we say p is a function of n is 2 minus 1/3 n, but this would be fine. I think I also took the answer if you did like p of n. You could rewrite it -1/3 n plus 2, that's fine, but that's how we would express it as a function of n. Any questions on solving this one? Okay. Not every relationship can be expressed as a function with a formula. If we try to express this relationship as a function, let's see what happens. So they want us to solve it for y. We have x squared plus y squared is 1. I'm going to take away x squared from both sides. I get y squared equals 1 minus x squared. And then I have to take the square root. But we know, don't we, from Algebra 2, AGS 2, what happens when you take a square root? What do you have to be careful of when you take a square root? So when we take this square root, we have a positive square root and a negative square root. So this cannot be expressed as a single function. However, so I want you to add that in the comment on GoFormative, but I want you guys to practice with that math text, and I want you to try and type it in with this plus minus. So we all agree this cannot be expressed as a single function, but I want to practice y'all typing in the plus minus square root. It's good to have practice with that formatting. Moving on, example 12. If you need me to slow down, you guys can use that reaction of go slower. Do you guys see that in the reactions? Okay, or just send a little message. We're asked to evaluate k of 2, given k of t equals t cubed plus 2. So we're saying k of 2 equals 2 cubed plus 2. So k of 2 equals 8 plus 2, thus k of 2 is going to be 10. The second one says solve k of t equals to 1. So whenever I have to solve one, I like to rewrite the original equation. Then I replace this with the 1, and we proceed to solve. Get negative 1 equals t cubed. How do I undo a cube? Cube root. And what is the cube root of negative 1? Negative 1. Because a negative times a negative times a negative is a negative. So in this case, t would be negative 1. We're given the function h of p equals p squared plus 2p. Evaluate h of 4 and then solve h of p equals 3. If, Jana, yes, if it had been square root and it took the square root of negative 1, then we would have had a plus and minus I. No, we would have just had I, I'm sorry, not plus or minus. Oh, what am I saying? All right, but luckily it was a cube root. H of 4, we're going to have 4 squared plus 2 times 4, so 16 plus 8, thus 24. So H of 4 is 24. H of P equals 3. Oh, goodness. So 3 equals P squared plus 2P. This is my favorite problem of the whole lesson because it brings back what type of function. We got to solve this for P. Should bring back memories of a specific thing you learned a few years ago. What is it? Elmer knows. Jana knows. Jaden knows. Yep, this is a quadratic. So the first step is to make it equal 0. So we're going to subtract 3 from both sides. So 0 equals p squared plus 2p minus 3. How do we solve quadratics? We factor it or we use the quadratic formula. Those are our options. We could also complete the square, but like that's just the quadratic formula. So if we're going to factor this, we need two numbers that multiply to negative 3 and add up to 2. They got to add up to 2 and they got to multiply to negative 3. And so we can set up our factored form. The two numbers would be, thank you, Joey, 3 and negative 1. Be careful. This is where I lose a lot of y'all. And y'all are like, oh yeah, the solutions are 3 and negative 1. Those are the factors here that are going to let us finish this formula. Our actual solutions, remember, are what make those parentheses equal 0. So it's negative 3 and positive 1 here. Our solutions, but yes, the numbers that we multiplied were 3 and negative 1. But don't forget about flipping those signs. Any questions here? All right, we're going to do the last try it now problem. It says given the function g of m equals the square root of m minus 4, evaluate for 5. So g of 5 is square root of 5, take away 4. So g of 5 is the square root of 1. So we're just going to say g of 5 is 1. Solve g of m equals 2.
Couldn't g of 5 also equal negative 1?
So since they've already indicated it's just square root and not plus or minus square root, no.
Oh, okay.
But if they had instead had like y squared equals m minus 4, and then we had to solve here, see how we get a plus or minus? But if not indicated and just shown as a regular square root, it's a positive square root. Okay, so g of m equals 2. So we're going to square both sides. So 2 squared gives me 4. And thus m has to be 8. Ta-da!
Mm.
Yeah, so if m were 0, we'd have the square root of -4, so then we'd have 2i rather than just 2.
Ah, I see.
All right, the next little bit here is talking about your basic toolkit functions. Y'all's job is to know the names of these functions and be able to identify if they are one-to-one and be able to match them to their graph. So our toolkit functions are shown below. In y'all's homework, it has you matching the names and the equations and the graphs. The ones that are one-to-one, I'm just going to put a quick check mark. This is one-to-one. Basic x cubed would be one-to-one. Not any kind of modified of x cubed here. This is one-to-one. This is one-to-one. That's one-to-one. All right. So that's it for the topics in this particular lesson. You guys, there is a homework already available. It's due for y'all on Friday morning. It's through GoFormative. Remember, you can find solutions to those practice problems, the exercises, in the detailed solution PDF that's on our textbook. Also remember, if you asked for a textbook, I did set them aside at school and they're available to be picked up tomorrow. Should have your name on them. There's a few extras there. If you did not put in a request, you could potentially still get one. If you send me an email, I can see what I can do by the end of the day. You also have the Pen Pals assignment.